The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, let's see here. So today we are going to wrap up section 10.2, and so let's get going on that. We're going to look at some problems involving the quadratic formula and some triangles and some rectangles. Okay, the first problem says the hypotenuse of a right triangle is 2.5 units long. The longer leg is 1.7 units longer than the shorter leg. Find the lengths of the legs of the triangle. Okay, so first of all, we're dealing with a right triangle. What does that mean? It means that we have a triangle that has one right angle or 90-degree angle. The two sides are perpendicular, okay? When you have a right triangle, the hypotenuse is always the longest side. Okay, and the other two sides are called the legs. So we've got the legs. Now, typically, the hypotenuse is labeled as C, and the two legs are labeled A and B. It doesn't matter which leg is A and which leg is B, but the hypotenuse has to be C. When this is true, when this is labeled like this, the following formula is true. A squared plus B squared equals C squared. So A, B, and C referring to the legs and the hypotenuse of the right triangle. This formula is called the Pythagorean Theorem. So the length of side A squared plus the length of side B squared equals the length of side C squared. We're going to be using this formula to solve this problem. All right. It says the hypotenuse of a right triangle is 2.5 units long. So this is going to be 2.5 units. Oops, units. Can't spell. Nothing new there. Okay. And then it says the longer leg is 1.7 units longer than the shorter leg. Okay, well, the way I've got it drawn, this is the shorter leg, so we'll call this X. And this is the longer leg, so we'll call this X plus 1.7 units. Okay? So A is X units long, B is X plus 1.7 units, and C is 2.5 units. So plugging these things into the formula, we get the following. X squared plus the quantity X plus 1.7 squared equals 2.5 squared, which leads us to X squared plus X plus 1.7 times X plus 1.7 equals 6.25. 2.5 times 2.5 is 6.25. Continuing on the left side, we get X squared plus X squared plus 1.7X plus 1.7X plus 1.7 times 1.7, which I think is 289. Let's see, 1.7 squared. Yep. So it'll be 2.89 equals 6.25. Combining like terms, 2x squared plus 3.4x plus 2.89 equals 6.25. Subtracting 6.25 from both sides of the equation, we get 2x squared plus 3.4x, and then let's see if we take 2.89 minus 6.25, we get minus 3.36 equals 0. Okay, now we can take this and plug it into the quadratic formula, but I'm going to go ahead and get rid of the decimals and reduce things down. So I'd have to multiply both sides by 100 to move the decimal point over 2 places. So I'm going to get 200x squared plus 340x minus 336 equals 0. Okay. Well, now that I've cleared the decimals, I also see that I could, in fact, take a 4 out of each term. So then I get 50x squared plus, let's see, what's 340 divided by 4? 340 divided by 4 is 85x minus 336 divided by 4. 84 equals 0. Okay. So after all that, I now have a second degree or quadratic equation. Its standard form, set equal to 0. I'm going to go ahead and recopy that on the next page. 50x squared plus 85x minus 84 equals 0. And I'm going to use the quadratic formula to solve for x. So a is 1, b is 85, c is negative 84, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 85 plus or minus the square root of, let's see here, 85 squared is 7225. And then it's minus 4 times 1 times negative 84, which is going to be plus 4 times 1 times 84 is 336 all over 2. X equals negative 85 plus or minus the square root of, let's see, 336 plus 7225 is 7561 all over 2. Now, let's see if 7561 is a perfect square. So I'm going to take the square root of that. Let's see here. It's coming out not nice. So hold on a minute. Aha. I found my mistake. My mistake was right here. That should be 50. That changes everything. I could start over, but I'm just going to go back and fix this. Okay. Once again, I need to slow down. Okay. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I knew something was wrong because it was supposed to come out nicely and it didn't. X equals negative 85 plus or minus the square root of, okay, so 85 squared is 7225, but minus 4 times 50 times minus 84 is going to be plus. So 4 times 50 times 84, 16,800 all over 100. Okay. X equals negative 85 plus or minus the square root of, let's see, 16,800 plus 7225, 24025 all over 100. X equals negative 85 plus or minus, and that, the square root of 24,025 is 155. There we go, all over 100. So x equals negative 85 plus 155 over 100. X equals negative 85 minus 155 over 100. Negative 85 plus 155 is 70 over 100 would be 0.7. Negative, let's see here, negative 55 minus 155 is negative 210 over 100, which would be negative 2.1. Now, this whole thing had to do with lengths of sides of a triangle. So the negative 2.1, even though it's a solution to the equation that we formed, it doesn't fit the actual problem because the distance can't be negative. So x is 0.7. So this would be 0.7 units. And then 0.7 plus 1.7 would be 2.4 units. So the question said, find the lengths of the legs of the triangle. One leg equals 0.7 units. Other leg equals 2.4 units. All righty. Next problem coming up. Imac Screens. The largest permanent movie screen is in the Panasonic IMAX Theater in Darling Harbour, Sydney, Australia. At least when this book was printed, it was the largest one. The rectangular screen has an area of 11,349 square feet. So now we're dealing with a rectangular screen, and the area is 11,349 square feet. Find the dimensions of the screen if it is 20 feet longer than it is wide. Okay, so let's call this the length and this the width. How about if we let the width be x, the length would be x plus, it said it was 20 feet longer, x plus 20, okay? So using the fact that area of a rectangle equals the length times the width, we get 11,349 equals x plus 20 times x. Or 11,349 distributing gives us x equals x squared plus 20x. I'm going to subtract 11,349 from both sides. So I get 0 equals x squared plus 20x minus 11,349. Okay. Now, we can't make those numbers smaller. So A is 1, B is 20, C is negative 11,349. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, a is equal to 1. X equals negative 20 plus or minus the square root of 400. Minus 4 times 1 times negative 11,349 is going to be plus, let's see, 4 times 1 times 11,349 is 45,396 all over 2. X equals negative 20 plus or minus the square root of, let's see, 46,396 plus 400 is 45,796 all over 2. And the square root of 45,796, let's see here. And we get plus or minus 214 all over 2. So these numbers are huge, but at least they work out nicely. So now x is negative 20 plus 214 over 2. X is negative 20 minus 214 over 2. So this is going to be what? 196 over 2, which is 98. I think that's right. Let's make sure. Negative 20 plus 214, 194. Let's see, negative 20 plus 194 divided by 297. Good thing that I'm checking my work here. I guess I'm having a Monday, even though it's Tuesday. So this is what? 194 over 2, which is 97. And then this is going to be what? Negative 234 over 2. Negative 234 divided by 2 is negative 117. Okay, you're going to start to see a pattern emerging here. We're dealing with a distance again, and so the negative answer won't work. Now, that doesn't mean you always throw out negative answers. Just if it's time or distance or length or width, it can't be negative unless it's in a science fiction movie. All right, so this would be 97 feet. This would be 97 plus 2117 feet. So the dimensions would be 97 feet by 117 feet. Okay. This next one is a bit tricky to follow. Here we go. It says Central Park is one of New York's best known landmarks. Rectangular in shape. Okay, so again, we're dealing with a rectangle. Its length is 5 times its width. So length, width. If we call the width x, the length would be 5x or 5 times the width. Okay? Now, when measured in miles, its perimeter numerically exceeds its area by 4.75. Find the dimensions of Central Park if we know that its width is less than 1 mile. When measured in miles, its perimeter numerically exceeds its area. So even though the perimeter is in miles and the area is square miles, we're just going to look at the number parts of it. Okay? When measured its perimeter numerically. All right, so let's see. The area would be length times width. So the area would be what? 5x squared. Okay? The perimeter, which is 2L plus 2W, would be 2 times 5x plus 2 times x, which is 10x plus 2x, which is 12x. Okay, so the perimeter is 12x, the area is 5x squared. All right, now, when measured in miles, its perimeter exceeds the area. So the perimeter is larger than the area in terms of the numbers numerically. By how much? 4.75. So the perimeter would be the area plus 4.75. So our equation becomes 12x equals 5x squared plus 4.75. Because if the perimeter is a larger number than the area by 4.75, by adding 4.75 to the area, they now become equal. Okay? Now, let's subtract 12x from both sides. So we get 0 equals 5x squared minus 12x plus 4.75. Let's multiply both sides by 100. So we get 0 equals 500x squared minus 1200x plus 475. 475, not 4.75. I could reduce everything by dividing by 25. So we get 0 equals, let's see here, 500 divided by 25 is 20x squared minus 1200 divided by 25 is 48x plus 475 divided by 25, 19. Okay. Okay. So now let's take this and go to the next page. 0 equals 20x squared minus 48x plus 19. Let's see here. So A is 20, B is negative 48, and C is 19. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. X equals 48 plus or minus the square root of, let's see, negative 48 times negative 48 is going to be positive 2,304. And then you've got minus 4 times 20 times 19, which is minus 1520 all over 40. So X is 48 plus or minus the square root of, let's see here, 2304 minus 1520 is 784 all over 40. And let's see if the square root of 784 is nice. It is. Plus or minus 28 all over 40. So X equals 48 plus 28 over 40, or X equals 48 minus 28 over 40. Now, 48 plus 28 is 76. Divided by 40 is 1.9. 48 minus 28 is 20. Divided by 40 is 0.5. And these are units of miles. Now, both these answers are positive, but the last sentence in the problem said, find the dimensions of Central Park if we know that its width is less than 1 mile. Since X is its width, it would be 0.5 miles, not 1.9 miles. So this is going to be 0.5 miles, and this is going to be 2.5 miles. So let's see, how did it say that? Find the dimension. So it's going to be 0.5 miles times 2.5 miles. All righty. Okay, let's see here. This problem, it has to do with a picture frame. Okay, so we have this picture frame that's a mat, they call it. It goes around this picture. And the picture is of a sailboat on some water, and there's some trees, and I'm not an artist, as you know. Here's what it tells us. It says the matting around the picture has a uniform width. So that frame around the picture is the same width all the way around, okay? How wide is the matting if its area equals the area of the picture round to the nearest hundredth of an inch? Okay, because it says round to the nearest hundredth of an inch, my suspicion is that unlike the previous problems, this one is not going to come out so nice. Now, what else do they tell us? They tell us that this distance from here to here is 5 inches, and this distance from here to here is 4 inches. Well, so those are the dimensions of the picture, not the frame, but the picture. So the area of the picture is what? 4 times 5 equals 20 square inches. Okay. Now, let me read it again. It says the matting around the picture has a uniform width. How wide is the matting if its area is equal to the area of the picture? So the area of the matting also equals 20 square inches. So the total area equals 40 square inches. So the matting plus the picture, 40 square inches. Since that matting around the picture is a uniform width, we could say that this distance is X, and this distance is X, and this distance is X, and that distance is X, and that's X, and that's X, and that's X, and that's X. In other words, it's X, that thickness all the way around. Why does that matter? Well, consider this, okay? Oops, didn't quite make it there. If this is 4 inches and this is x and this is x, then wouldn't this be 2x plus 4 inches? Okay, and then here, if this is 5 plus x, that would be 2x plus 5. So the dimensions of the entire thing, that is to say its area, which is 40, is 2x plus 5 times 2x plus 4. I can write that a little nicer. Okay, all right. So 40 equals 4x squared plus 8x plus 10x plus 20. 40 equals 4x squared plus 18x plus 20. Subtract 40 from both sides. 0 equals 4x squared plus 18x minus 20. We could divide everybody, reducing out at 2. 0 equals 2x squared plus 9x minus 10. All right, let's take that to the next page. 0 equals 2x squared plus 9x minus 10. And let's use the quadratic formula on it. A is 2, B is 9, C is negative 10, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X is negative 9 plus or minus the square root of 81 plus 80. Negative or minus 4 times 2 times negative 10 would be positive 80 all over 4. X equals negative 9 plus or minus the square root of what? 161 all over 4. 161 doesn't come out nicely. Okay. I just recopied what was below, so hang on, let's do this. So we're going to have that or that. Okay, the plus or the minus. Again, don't forget parentheses around the entire numerator and parentheses around the radicand. So we're going to have that, and then here and here. So for the first one, parentheses, negative 9 plus the square root of, negative 9 plus the square root of 161, all divided by 4, is 0.922, etc. And then, let's see here, minus divided by 4. Hang on, parentheses, negative 9 minus the square root of 161 divided by 4. Negative 5.422, etc. Okay, now, again, we're dealing with a distance or length. So again, we throw out the negative, and it said to the nearest hundredth, so that would be what? 0.92. So the width of matting equals 0.92 inches. And there you have it. Okay. Well, that's all I've got for you today. So for tonight, finish up section 10.2, and I'll be back at 1:15 with an office hour should you have need of me. Bye now.